This lesson goes over section 5.1 models of the atom. First we're going to do a short review. The Dalton model stated that atoms were small, indivisible, hard round spheres. And you see a picture here, there's no detail to it, whatever, it looks like a marble. Thomson came along, he discovered the electrons, so now you see these electrons showing up throughout the atom, and he stated that electrons were suspended in the atom, and the majority of the atom was a positively charged gel-like substance. So the electrons were suspended in a positive gel. That's why his model was called the plum pudding model. I think it works better if we call it the chocolate chip cookie model, where the chips are the electrons and the cookie is the positive gel, the rest of the atom. Rutherford discovered the nucleus, so now you see the nucleus in the center. He stated that the atom was mostly empty space and that it contained a nucleus which was very small, very dense, and positively charged. And the electrons surround the nucleus. And while this model has a lot of validity to it, it doesn't explain chemical properties or why elements in the same groups or columns behave in the same manner and have very similar properties. So Bohr came along and kind of, Bohr's model is very similar to Rutherford's model. The only difference is that he has these specific energy levels that the electrons reside in. Rutherford said the electrons were just around, but Bohr said they had to be in specific energy levels. His model is often called the planetary model because it resembles the planets rotating around our sun. He said that electrons travel around the nucleus in concentric circular paths. He called these orbits. Each orbit or energy level has a specific amount of energy attached to it. We talked today in class and said that the energy gets higher the further you go from the nucleus. And electrons can jump to a higher energy level if energy is added. So if I add energy, there's this picture here shows the electron jumping to a higher energy level. If the electron's on a higher energy level, it can emit energy and fall back down to a lower level. This specific amount of energy is called a quantum. So quantum is defined as the amount of energy required to move an electron to another energy level. And as we saw today in class, the energy levels are not spaced out equally. This is actually kind of showing in reverse. The energy level, this picture shows better. The energy levels get closer together the further they are from the nucleus. This circular picture is showing the opposite, so there's a problem with that. Another point to his model is the idea that energy is quantized. What that means is that light's emitted by atoms in a specific packet of energy. If something's quantized, it's very specific. For example, stairs. So if you think about the stairs downstairs by the chapel, I can walk up the stairs and I can only stop at a very specific point. But next to the stairs is a ramp. And on that ramp, I can stop anywhere. So again, on the stairs, I can only stop on a stair, but at the ramp, I can stop anywhere in between. So stairs are quantized, and the ramp would be continuous. Okay, a ground state is, and we'll talk more about quantized energy and ground state later. But a ground state is defined as the lowest energy level of the atom. Excuse me, this should say of the electron. So when the electron gains energy, that electron becomes excited. And when it's excited, it jumps to a higher energy level. We call that an excited state. Be like if I'm sitting on the couch watching Georgia play Florida and Georgia scores a touchdown. I get excited and I jump up off the couch into the air. But just like me, electrons can't stay excited forever. So they're eventually going to lose that energy. So, and this should say electron again. So when an electron loses energy, it emits light. Sometimes it's visible light, sometimes it's ultraviolet light or infrared light. So when the electron loses energy, they emit light as they lose that energy. So if we look at this picture, here's our ground state of the electron, the lowest state. The electron resides here. That's its normal resting place, just like you on the couch at home. When it gains energy, if it gains the amount of energy from the ground state to this level B, it's going to go up to this level. And these two are both excited states. So that's why it's showing these electrons with stars around them. They're excited. The one at B is not as excited as the one at A because that A is in a higher energy level. So up here it's got a lot of energy, but it's going to lose that energy. So when it falls back down, it gives it off in the form of light. And again, we'll talk more about this later. The last type of model, and actually the way we think of the atom today, is the quantum mechanical model. Sometimes it's called Schrodinger's model because Schrodinger was the one who came up with this idea. And it's based on probability. He used math to calculate the probability of where an electron would reside. He said that electrons are restricted to certain energy levels. Capital E is energy. The electron doesn't have an exact path, so that's where the quantum mechanical model differs from Bohr's model. Bohr had these very specific places where the electron resided. It could reside in this path, or this path, n equals 2 or n equals 3. Whereas the quantum mechanical model just says, well, it could be anywhere within this area. The quantum mechanical model estimates the probability, or the likelihood, or the chance. I should say, I guess that's wrong, the probable locations. So it estimates the probable locations of finding an electron in a certain position. This would be referred to as an electron orbital. And that's the orbitals that we talked about today. And again, these are probable locations. They're the orbitals or the energy sublevels. And we talked about the S, the P, the D, and the F. So here's a picture of an S orbital. And a lot of times it's called an electron cloud or a fuzzy cloud. So this area is where we would most likely find the electron. The electron could be out here, or it could be kind of in here or here. It's most likely going to be in this red area. Now, it's a cloud because it's not a defined edge. Like clouds don't have defined edges. If you've been lucky enough to fly on an airplane and fly through a cloud, it's hard to tell where the cloud begins. It just kind of gets foggy looking, and then it gets a little bit foggier and a little bit foggier, and then really thick. So this edge isn't well defined. That's why it looks like it kind of dies off. And typically this is the 90% chance where you would find the electron. And that ends the lesson for today. Make sure to ask questions about anything you didn't understand. We'll have time tomorrow in class for that. Have a good night.